Okay, today I'm gonna kind of break this up into two parts. Part one is just more of a review of what we're building this semester, um, and some of the requirements that are going to be in the project. Part two, we're going to get into actually working through the lab together, O2O2. And so this first part is a really important part to understand the semester long project that as you do your labs, every lab kind of builds on top of. And so this project ends up being a larger scoped project than most of our smaller labs or smaller homeworks or whatever it may be. Um, and so, again, just kind of reviewing what we're building this semester. So, I encourage you to open up the lab and just kind of follow along and ask questions if you have them. Um, and so, Lab 0202, now, again, this is just kind of an overview. It says we will build a large web application over the course of this semester. So, first sentence there. Um, and I want to kind of drive this home, the importance of this. Um, when it's time to interview, when it's time to, kind of put the books away and, time to get that first job, um, a project like this, what we're going to build, can be the difference maker between, landing a job and not landing a job. It can be a serious difference maker. I can't tell you. So I've been teaching since 2006, and I can't tell you the number of times that a recent graduate interviewed and said, "Mr. G, my employer told me that they selected me because of this project, because I demonstrated not this project necessarily, but a project that they built in school." And so, literally, building it, deploying it, getting it on your portfolio as a demonstration of your work, not just the GitHub repo, but a usable piece of software that you can go to an employer during an interview. You can show them what you built. You can show them not only the source code, but show them this in a working form. Literally, this happened within the last month that I had a May graduate. It's 2023. Had a May graduate interviewing with many other students, and he came back to me and said, "Hey, I got selected for this job because they were impressed of this thing that I built." And actually wasn't this class, but it was the next class that you guys are in, which is a C sharp class. And that's happened many times in my career where a student has given me that feedback. So I know that a good demonstration of your work is one of the most important things that you can do to help you land that first job. That first job is always, always, always the hardest one to land because once you get a year of experience, once you get 3 years to 5 years experience, you're golden, right? If you can get a year experience, you're good. If you can get 3 to 5, you're golden. And so it's always that first job that's the hardest to land. And a diploma is important, but a good demonstration of your work is as important as that diploma. I would put it that high on how important it is. Um, Along the way, we will learn and apply a wide variety of development skills. This project will be progressively enhanced as you move throughout the theory and lab components of this course. Um, so again, this project is outlined below. Um, basically, we at Rankin kind of got our inspiration from this video, where this guy outlines a good coding project that can really help you land a job. And more or less, he makes a bunch of really good points that I agree with. And so it's like, yeah, let's do that. Let's build an issue tracker. So in the course, we are building an issue tracker, or a bug tracker, or a ticketing system. It can go by a bunch of names. I would even put AKA ticketing system, AKA bug tracker. It can go by a bunch of different names. It could take many different forms. Um, but if you're kind of viewing it from the view of a software development perspective, maybe a bug tracker would be the best name, because the idea is like, hey, end users find bugs in our software, or someone, a customer, a manager, someone finds a bug, they report the bug, and then it's tracked until that software bug is resolved, right? So you can put a bug in the system, you can update the bug with notes and say things that you've done to work on it, and its current status is, being worked on, kind of thing. And ultimately, in a perfect world, all of our bugs get resolved, therefore they're closed. So maybe a bug tracker, you know, in the scope of what we want to build, is really a issue tracker, or a bug tracker, I think is a good name for what we're building. Again, this will account for most of your lab assignments and be turned in at the end of the semester as your final project. I started a week ago with getting this deployed, right? We deployed the current version of the issue tracker on Google Cloud. And I just want to highlight that that is a really good exercise to follow along with. If you didn't deploy it to Google Cloud, I would recommend doing that. It does require a credit card. It does not auto charge your credit card. Because it requires a credit card, there's no grade associated for it. So it's kind of like, hey, this is a good thing for you. I recommend it, but there's no grade associated with it. Because what we will be doing is, as this course progresses, we will continually deploy it. And so we did deployment in the beginning, and the plan is to, every time we revise it, kind of update the deployment. So what is an issue tracker? Now, this kind of comes from uh, Zendesk, which is a ticketing system. Maybe you've heard of Zendesk, maybe you haven't, but this is pulled right from Zendesk website. Again, just kind of reading through this because I think it's important. Software development is complicated. Even the most highly skilled software engineers in the world write code that has bugs. Um, so, you think of some of the best software in the world, be it um, like Apple's iOS, or, you know, um, obviously something that has been around a long time and always has bugs, but Windows, for example, there's that when Microsoft was first founded, it was because of the Windows operating system. And so certainly there's a lot of talented software developers that went into building Windows, but it doesn't matter, all software has bugs. So even the most talented developers in the world write software that has bugs. Often referred to as a bug tracking system, these tools present organized way via tickets for customer service and product development teams to address issues efficiently while providing users with status updates. Um, I might have hopped over. Da, 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 da. Yeah, I skipped over to this first paragraph. There, let's see. Da, da, da. So, yeah, even the best software developers write code that has bugs. There's really no such thing as a software that's free of bugs. However, fixing software issues, while challenging, becomes easier when companies use issue trackers. So, you're using software to track the bugs in your software. Simply put, an issue tracker records issues customers have experienced with the software product, and it enables support agents, engineers, and managers to track those problems until they have been resolved. So typically, it's an end user, it's a customer of your software product that's going to say, hey, this software isn't working the way that I think it should. um, and therefore there's a bug, whatever that bug may be. In a typical tracking system, a customer service agent can assign a priority level to a ticket, like P1 to P4, P1 being the most severe. Those priority levels will be adjusted for development teams, project managers based on team resources, development roadmaps, and feasibility. So you kind of rank them in priority of high priority bugs to low priority bugs. Sometimes tickets are closed when an issue cannot be reproduced or is determined inapplicable. So just a little, again, just kind of pulling it from the Zen tracker, just understanding what a bug tracker is before you try and build it is kind of what we're doing. Issue trackers are used by software development teams to track work that is planned, needs to be done, and has been completed. Got a team of developers, and so you want to work as a team and kind of update everyone and communicate through the software of kind of the status of all these different bugs. Gaining familiarity with such systems will give you insights into both how software teams operate and how various features can be implemented. These skills should serve you well regardless of the employer you work for. So popular, there are plenty of ticketing systems out there. So um, the reason these links are here is because if we're building a ticketing system and that already exists, you can gain inspiration from other softwares that are out there if you understand those softwares. Uh, and so my recommendation here is to look at these different ticketing systems, see how they work, and see what kind of features you may or may not want to build into your software. Um, and so these links are for you to kind of just be familiar with what's already out there. Um, so when it comes to this application, the question that I often get is, uh, you know, are we all going to be building the same thing? And in some ways, yes, and in some ways, no. We're going to have some requirements that we do ask for, while at the same time allowing for lots of flexibility in the user interface and in maybe in the database design. Maybe everyone's database is a little bit different. While still incorporating the minimums that we're asking for, there's flexibility in how you deliver your solution. And so not everyone solves the problem the same way, and that's okay. And so I'm expecting at the end of this class, if we have 15 students or whatever, we get 15 similar but yet very different end solutions, if that makes sense. And so you're going to see that some of these application requirements are specific and some of them are more vague and allow kind of for some different implementations. Now, what I recommend everyone do is these application requirements. Some of these are here and do apply directly to the database, and that's what this assignment is. This database is beginning the database design. Okay, so in the summer playlist, okay, I put a couple of videos yesterday of just some database design best practices. Okay, there were maybe like an hour worth of videos directly from Mongo, and you want to watch those videos, okay, because we're going to be what I would call a first draft of our database. It's by no means the final product, but it is a first draft of our database. So you want to watch those best practices um, before getting into this lab. But kind of back to the application requirements. Some of these requirements will affect your database. Some of these are requirements that really don't make a difference today. They'll make a difference later. And so, for example, step three, users can log in with their email address and their password. Well, we're not logging in today. We're not doing anything on the front end. We're quite a ways away from, building a login system. Um, but we're getting there. Point is, that's an application requirement that we're not going to necessarily. It might affect our database design a little bit, but you know, some of this you'll need for later. And so basically, long story short, what I want you to do is download this file, maybe download it as a PDF, okay, and make a separate folder somewhere on your computer, and save these application requirements so that you can easily come back to them, because you're going to get a few of these where it's like, hey, I'm putting these application requirements in there for you. Ultimately, you'll need these for your finished project. Okay, so definitely save it somewhere where you're going to be able to access it again and remember where it is. Okay, so these requirements, when it comes to software development, one of the first steps is basically meeting with your users and gathering requirements. What does the software need to be able to do? Okay, so in the software development lifecycle, the SDLC, right? Step number one oftentimes is meeting with end users, and they're going to tell you what they want. Um, and so these requirements are written from the point of view of a customer, right? An end user. This is what the customer wants. This is not the point of view of a developer, more of a point of view of a customer, right? And we have to interpret what the customer wants and build it. Um, and so, kind of step one here says the core entities are bugs and users. So those are at minimum, okay, the two collections that we're going to have in our database. Okay, there can be more, but there doesn't have to be. Okay, so that's kind of the flexibility that I was talking about. You might end up with you might end up with 8 collections in your database. Some of you might end up with 8. Some of you might end up with just these two, and everything would be nested within bugs or nested within users. Okay, you might end up with, like I said, 2. You might end up with 4. You might end up with 8. There's flexibility there, but at minimum, right, your database is going to have bugs and your database is going to have users as collections. And so, when it says the core entities, those are your core, those are the things, right, the nouns of your software, the things, person, people, places, and things. When you have a user, so these are required for all users. So again, this is kind of an application requirement when they're registering, right, for an account. These are all required fields, right? So you can kind of envision an account registration. You have to put in an email, a password, a full name, a given name, which is essentially your first name, your family name. Now, probably you're going to take a given name and a family name from an end user and combine it together for the full name, right? So it's required as long as they give you the given name, which is the first name in America, and the family name, which is the last name in America. And the last thing is each user is going to be assigned a role. And if you've ever used different software products, a role is another name for a group. Okay, we're going to talk about the different roles that exist in our software, but all users will have at least one role. Okay, you can have one or many roles as an end user. Okay, users log in with their email and password, pretty standard bit. Now, yeah, I'd say that's standard. Sometimes you log in with an email, sometimes it's a username, right? So in our software, you're logging in with your email and your password. Again, that's not always the case. Again, so the different roles, and we're going to talk about as we go through the class. Um, uh, there are uh, authorization, and authentication. Um, so authentication is username and password, right? Authorization is okay, you put in your username and password, but are you authorized to get to this website? And so you will be granted access, you will be granted authorization based on your role, right? It's very standard in IT to give a user account a role or a group, and then you assign permissions to the group to grant or deny access. And so that is all something that's built into this course. Your users will have roles. These are the valid roles. Um, you know, if it's not in this list, it's not a valid role. So, you know, there's no, there's no administrators. Okay, in some software, there's a role called administrators. Uh, doesn't exist here, right? So the valid roles are listed. If it's not in this list of roles, it's not a valid role. Okay, any user can create a bug. So basically, all of these roles, they can all of them can create bugs. You're going to notice there's no customer also. So end users cannot create bugs in our software. That again, that's going to vary from software to software. A lot of times the customer or the end user would be able to create a bug. Not the case here. Okay, but if you're a user, um, you're going to be assigned one of these roles. None of these are end user roles, therefore end users, uh, you know. Uh, anyways, if you're a user, there is no end user here. Any user can create a bug, and a bug has the following information. Again, must contain, aka required fields. So these are required fields for users. These are required fields for bugs. Now, we can enforce that validation a lot of different ways. You really can't enforce that in the database. Uh, there are some ways to make sure that you don't have duplicate. You can have unique constraints. But keep in mind, Mongo is pretty flexible and they kind of let you put data in however you want. So we're going to have to enforce. We're going to have to enforce these rules at the application tier, maybe on the front end, maybe in the middle tier of the application tier. But um, these are the fields for bugs. So you know the fields for users, and you know the fields for bugs, right? So as we get into this lab, you have some good information to how to begin your database design. Okay, any user can edit the bugs they've created. So if you didn't create it, you might not be able to edit it. That kind of depends on your role. But if you create a bug, you are able to edit it. When a bug is created, then you can assign the bug to certain roles. And so, maybe a product manager creates a bug, and then you can assign it for a developer to work on, a business analyst to work on, or a quality analyst to work on. Again, those are all different roles. And so these are the different roles that bugs can be assigned to. These users can modify the bugs that they're assigned to, but not bugs they did not create or not assigned to. Okay, so you create a bug, you assign it to a user, then that user can modify it. But if they didn't get assigned that bug or they didn't create it, they cannot make edits. Number 9, and we'll do this as the lab goes, as we do more labs. It says all edits must be tracked. So that's an interesting requirement that as edits are made to a bug, you could say like last edit. And so there's a date and time, who made the change, and what was changed. And so that's kind of highlighted because that will be something, again, we work on it as the semester goes. Um, but that's a important piece. Let's see, just going through this one at a time. Anyone can add comments to a bug regardless of who created it or who it is assigned to. These comments must include author, date, and time of creation. Bugs can have multiple comments. Um, so, um, kind of similar to, um, our movies. A bug can have comments. Well, I think it was our movies had comments. A bug can have comments, and so you can kind of talk about the status of a bug, what's being worked on, what's happening to the bug, and um, so it doesn't really matter who your role is. Anyone can comment on a bug. Once a comment is put in, you cannot make edits to that. So comments are kind of kept for historical purposes. And then it gets into, again, these are requirements for later on. Um, but what can the different roles do? Business analysts can classify bugs, approved, unapproved, duplicate. By default, bugs are unclassified. Um, and so, uh, it says all bugs must contain the following information. Here, it doesn't really talk about bug classification, but I'll add, because down here it does say that bugs by default are marked as unclassified. So there will be a classification of your bug, and I'll even mark approved. So those are kind of the four classifications that you can have: approved, unapproved, duplicate, and unclassified. Quality analysts can add test cases to bugs and mark them as pass failed. And so, kind of high level overview of what that is. Bugs can have multiple test cases. What is a quality analyst? A quality analyst is someone who looks for bugs in software, and they use software to test their software. So we write software in a lot of cases in these classes, and we test them ourselves, manually testing. But when you write software to test software, that's called a test case, and it's the job of QA, or quality analyst, to find bugs in your software and say whether those bugs still exist or whether they've passed. If they pass their test cases, that means they've passed all of the software checks, and essentially a bug has been resolved. So if it passes the test cases, it's a good step towards resolving bugs. Um, and so the test case could be added to a bug, because a bug can have one or many test cases assigned to it. Again, that could be its own collection, it could be a part of a bug, it could be a nested document. So there's some flexibility there on how a test case, whether it's its own collection or whether it's nested, that's up to you. Developers can track the amount of time they spent on a debug. On a bug, developers submit hours multiple times. So, um, you know, most uh, jobs, when you're working, you log your hours and you say, hey, for 4 hours I did this today. Developers often do that in these ticketing systems. They're like, hey, I spent 6 hours working on this bug um, today, and 4 hours tomorrow, and 3 hours yesterday. Um, so again, time in hours, um, and again, how that gets logged in the database is flexible. Developers can note what version on the software. Let's see. Developers can note what version of the software the fix will be released in, and when the fix was made in the code. So when you fix your software, you go through the versions. I think we talked about the semantic versioning system, right? Where you got major version, minor version, and bug fixes with the dot notation. Um, business analysts can close bugs. And so finally, when a bug is resolved and basically all the tests have passed, all the test cases have passed, then you can close a bug and it no longer exists. Okay, so that's just kind of a high level. I'm trying to paint a picture of what the end product is going to have. Some of this will affect us today. Some of this will not affect us today. Some of it's just kind of forecasting into the future, the software that we're going to build. Again, my recommendation is download this, put it in, a root directory somewhere where you can come back to it, and call it application requirements V1 because there will be a V2 and a V3 and a V4. Okay, because there will be more uh, things that we build into the system than just this. Okay, but this is a base layer. Now, today, today's lab, um, um, I'm going to break this video up into two parts, and we'll actually get into building some database for, or what I would call the rough draft. Call it a rough draft of our database schema in Mongo. Um, Grant, you're online with me. Got some feedback for me. What was that a good overview or learn anything?
Yeah, I don't really have any questions.
Okay, right on. Okay, so that's an overview of the issue tracker. We'll stop it here and then we'll get on to the lab.